Welcome civil engineering community to this video about a geotechnical study. We are going to introduce our results for shallow footing design. We are going to start by introducing the project, then the type of data collected, our method to design the foundation, followed by our final dimensions and verifications. Later in the presentation of the ground data and soil characterizations, and finally a brief conclusion. The project consists of the construction of a six-floor hotel and office development in the Leith area of Edinburgh in the United Kingdom. So the study was made according to the Eurocode 7 classifications.
In this part, I'm going to talk about the planning of dimension foundation. First of all, we took all the useful information from the project. From this data, we have drawn the necessary curves for the study of our foundation with the different depths. We determined that depth of the foundation equals 3 meters because we have clayey sand and the project is near the sea. From this planning, we identified the properties of the soil, the depth and bulk density, the ground water level, the shearing force, and for the long term, we have determined C prime and phi prime, and for the short term, we have determined Cu and Phi.
Before we start our study, 4 borehole logs had already been done on the construction site. As those boreholes haven't been cast at exactly the same location of our foundations, we had to interpolate the ground conditions from the adjacent boreholes. So, to do that, we've created a 3D view of the soil from the borehole logs. This abstract object had permitted us to see the relation between the 4 logs and the continuity of the different veins of soil. We've used the shear box test results in order to find the effective stress parameters of the soil Phi and C. After having confirmed that the soil studied is loose, we've done a summary table with the results and the characteristics of the soil studied. As we had some undrained triaxial test results, we've determined the total stress parameter Cu. With all the parameters we had, the use of more circles was an option, and as we've assumed that the strength envelope for Phi equals to 0, we take Cu as the radius of the circle.
To design the 3 foundations, we established our calculations by applying the major hypotheses. First, that we are designing shallow foundations. Second, the soil resistance equals 2 bar. Third, we applied the homothetic method in order to determine the length and the width of the foundations, with nu representing the force applied to each column. Since each column is shape square, the same thing applied to the foundations. The height is calculated by adding the value of D to the concrete cover, which is 3 cm, to be aware of any sort of chemical effects. We added 1 cm also. Taking foundation A, for example, we get 2 by 2 by 0.5 meter in each dimension.
To size our foundation, we applied the bearing capacity calculation according to the ULS Eurocode 7. We have to determine the safe bearing capacity and the net ultimate bearing capacity for 2 conditions, long term and short term. For these 2 conditions, we must justify the punching shear using the following formulas. For the case of long term, we verified the punching shear, but in short term, we realized that condition of punching shear is not justified in all 3 cases due to the presence of clay and being in presence of groundwater near the sea. So we increased the dimensions of the foundation in order to verify our design.
This project is the outcome of all the lessons we've taken all over our university years. Thus, we had to use our knowledge of granular materials, hydraulics and soil mechanics, as well as our expertise in geotechnical design to Eurocode 7, together with the design of concrete structures to Eurocode 2. Furthermore, this case study has allowed us to understand the relevance of soil geotechnical properties when dimensioning foundations. Although we are engineers upon formation, we've handled the Eurocode in order to size foundations. Thus, we think that from now on will be able to make better assumptions and deal with other geotechnical projects. Finally, even if none of our members of this group will continue the courses of geotechnical engineering next semester, all of that we've studied here will be useful in our careers.